In this video, we're going to talk about quadratic models, so quadratic word problems. So in this video specifically, we're going to do standard form, and in another video, we're going to do vertex form and then factor form. So for this video, I had done a whole video. I made this whole video, but it was not the function didn't work out nicely, and most of the problems that you're going to do are going to work out pretty nicely. So I wanted to redo it because it was taking way too long, and I didn't want to put you through a 20-minute video on a problem that's not you're not going to be taking that long for most of these videos. So let's talk about this problem. So a ball is shot into the air from the edge of a building. The height of the ball in feet after t seconds can be modeled by this function right here. So the first thing we need to do is identify our variables. So first things first, we have, oh, I got a low battery, hold on. Okay, so the first thing we're gonna do is identify my variables. So I have the height of the building after t seconds. So first thing I'm gonna do is t. So t is pretty clear what it is. Usually t is time, and it's in seconds. And is t going to be my x or my y? Well, you see how it says h of t here? Kind of like how we've had f of x, where f of x was y, but x is our variable inside. So here, t is kind of like my acting x. So it's my x-axis. And then I have h of t, which is height, the height of the ball in feet, and that is my y-axis. And we know that because this is in function notation. It's kind of like, again, f of x. And then I'm going to do like a little mini sketch of what we're looking at here, because I think that's helpful for all these problems that we're about to do. Hold on, before I do that, let me put some space. Okay. So here, what we're really dealing with is a function that looks, it starts at some point because it starts on a building, right? It's a shot into the air from the edge of a building. And it's shot into the air, and then it comes back down. So there's your parabola. Technically, if we're really getting technical here, right, our parabola really continues down here infinitely and down here. But those parts of the parabola don't really matter because the balls, if this is h and this is t, right, time and height, if this part of the parabola existed, we'd be communicating that the ball's gonna bust through the ground, which it's not. And then if this part of the parabola existed, we would be communicating that we can go backwards in time, which we can't. We can't have negative time, and we can't have negative, I mean, we could have negative height, and some problems do have negative height, but in this context, logically speaking, if I threw a ball into the air, what would probably end up happening is it would hit the ground and then bounce back up. It's not going to just bust through the ground. Anyways, moving on. It's really important for you to understand what the context of the problem is. Context is key here. It's not just, oh, I gotta find the x-intercept. Like, no, what is the context asking? So the first question here is, how high is the building that the ball was thrown off of? So first of all, key words here. How high, right? So that immediately tells us we're looking for what? Height or time? Height. So we're looking for an h value. H equals something. Okay? Immediately, we know h is height. How high? How high is the building that the ball was thrown off of? Meaning, where did we begin? How high was this building? So again, this diagram, we can kind of visualize this is a building. This is the building that it's being thrown off of. And here's my starting point. So I'm going to delete it so that we see it. So here is my starting point. And so we need to find my what? My y-intercept. Because this is at t equals 0. Actually, it's technically my h-intercept, my starting height, right? My starting height. So it's my h-intercept. So how do we find our y-intercept, quote unquote, or our h-intercept? Is we need to set t equal to 0. So, oh, we lost some of our parabola. It's okay. We need to set t equal to 0. And with standard form, it's easy because standard form, our c value is just our y-intercept. So h of 0 is equal to 80. So how high was the building that the ball was thrown off of? 80 feet. This is not a logical, it's not that logical. I mean, 80 feet's not that illogical, but it kind of is. 80 feet. The building was 80 feet. Next, how long did it take the ball to hit the ground? Now, keywords. How long? Meaning, what are we dealing with? Time or height? We are dealing with time. So we're looking for a t equals. Okay. Now, how long did it take for the ball to hit the ground? Meaning, h, what's the height at the ground? The height of the ground is 0. So that means this is going to be h equals 0. So we are looking for the x-intercepts or the x-intercepts, which are really the t-intercepts, right? Because we're not really using x, but like that's what we're used to. So we're looking for the t-intercepts, which is right there. And technically it's right here. So we're going to get 2. But as we'll see when we find it, one of them is going to be completely canceled. The other one is valid. The other one's canceled. So let's find it. Now, how do we find the x-intercepts of a quadratic in standard form? There's 2 ways. So in standard form, and we went over all of this, but just a reminder, we can use factoring and we can use the quadratic formula. Now, I am going to use factoring because in our equation, we have a GCF. Negative 16 is a GCF because 64 and 80 are both divisible by 16. However, and this is what the issue I ran into with the last problem, and this is why I'm redoing this entire video, is because sometimes it will not be as pretty and you have to use the quadratic formula, but it does get annoying. Trust me. So I'm going to do factoring by taking out the GCF. So I have h of t is equal to negative 16t squared plus, what is it, 64 and 80. So 64t plus 80. So the first thing I'm going to do is I'm going to take out my GCF of negative 16. And I get t squared minus, because I'm dividing this by negative 16, 4t plus, nope, minus 80 divided by negative 16 is negative 5. And then I can use reverse FOIL here and factor this trinomial. What multiplies to negative 5 and adds to negative 4? We're dealing with t minus 5 and then t plus 1. And then I use my t-chart. Again, this doesn't make a difference because it's never going to be 0. So this doesn't matter. And so I get t is equal to 5 and t is equal to negative 1. So let's look back at our graph. Right? If these are our 2 t values, boom and boom. Here's that negative 1 and here is that 5. Can I say that after negative 1 seconds, the ball went backwards and hit the ground? No. But I can say after 5 seconds, the ball hit the ground. right? That makes logical sense. So this negative value gets canceled by this one does not. So I can say the ball hits the ground after 5 seconds. Okay, now, what is the maximum height of the ball? Keywords. Maximum is our first keyword because that tells us that we have to find what? It tells us that we have to find the vertex immediately. Hello. Vertex. This immediately tells me I need to find the vertex, but it's asking me what the maximum what is, the maximum height. So this tells me that, let's keep the pattern here. Height is telling me that I need to find what? H or T. It's an H value. So that means I need to find the Y value, right? Because right now we're dealing with T and then H of T. That's my X and that's my Y. So H of T is what we're dealing with here. So let's find it. How do we find the vertex of something in standard form? Well, we have to find the axis of symmetry. So x equals negative b over 2a. So my function, I'm going to rewrite it over here. H of t equals negative 16 t squared plus 64t plus 80. So a is equal to negative 16, b is equal to 64, c is equal to 80. So negative b over 2a is negative 64 over 2 times negative 16, which is negative 64 over negative 32, which is just 2. So then I plug it in. And so h of 2 is equal to negative 16, 2 squared plus 64 times 2 plus 80. So I get negative 16 times 4 plus 64 times 2 is 128, right? 60 times 2 is 120, 4 times 2 is 8, plus 80. So I have 16 times 4 is 64, negative 64, plus 128, plus 80. This right here is going to be, this is 64 plus 80, and 64 plus 80 is 144. So my vertex is 2 and 144. So that's up here. Let's come back up here. Right here. 2 and 144. So now I need to use this information in order to answer the question. So the question is, what is the maximum height of the ball? Well, the maximum height, h, is going to be 144 feet. 144 feet is the max height. And then the next question is super easy because we already pretty much found it, right? So again, key word here. How long does it take for the ball to reach its maximum height? So we're still dealing with the vertex, right? But it says how long, which means that here we are dealing with time. And so, again, we already found it, right? It's right up there. After 2 seconds, it reaches its maximum height. So it takes 2 seconds to reach max.